This is part 3 of our videos on potential energy, kinetic energy work, and the relationship among the 3 of them. So we left off on this slide, and I asked what happens to the potential energy as the object falls to the ground, and the answer to that is it's converted to kinetic energy. But then the next question is, what happened to the kinetic energy? And I don't want you to ever tell me it went into the ground, because I don't know what that means, because if that's the case, then apparently we're losing energy, and that's not possible. So tell me about some of the other kinds of energy, because what happens when you fall to the ground? It makes noise, so some of it becomes sound. It actually warms up some. It gets deformed, so that some of it goes into work to actually move things around in the book. And some of it goes into warming the ground as well. So I mean, I guess technically some of it goes into the ground, but it goes into the ground in the form of heat or some change in the kinetic energy of the particles. So let's consider here some of the types of potential energy. We're talking gravitational here. We're going to talk for the rest of this video about elastic potential energy. We will do electromagnetic potential energy in the second semester. We really don't do chemical potential energy too much. And rest potential energy goes back to Einstein's famous equation E equals mc squared, that all mass has potential energy regardless of its situation, because it's composed of mass, and mass can be destroyed in nuclear reactions to create energy. But let's go back here and let's talk about elastic potential energy. One of the places where I think about elastic potential energy is in the pole vault. So here I have a stop-action picture, actually kind of a revolutionary picture back at the time it was done, of a man pole vaulting. And you may notice in this that he has the pole, he's running, he plants the pole in this, referred to as the box, and then he uses the pole to then push himself up and over a bar. So what he's doing here is he's converting his kinetic energy into potential energy, into doing work to lift himself up, so he has potential energy at the top and back down. Now this is a pretty straightforward, he's got kinetic energy, he uses a lever essentially to change the direction of his motion into work to cause his body to be lifted up and over the bar, so he has a successful vault. But something happened along the way to the technology for pole vaulting, and we have this happen now, where the man runs, he plants the pole, he then bends the pole, because now they're made out of fiberglass. If we back up here, I don't know what this is made out of, but a lot of times they were made out of like bamboo. Very strong, sturdy wood, but not very bendable. Now the pole is bendable. So the pole actually stores energy in the form of elastic potential energy. So he can run down here, plant, store some elastic potential energy in the pole, and then use some of that by getting it back out and throwing himself up and over the top of the bar. Here's one that's stop action using the more modern fiberglass pole. You can see that he has stored elastic potential energy in. He's then getting it out to push himself up, and then the athletic part of this is the running, and then the timing and the ability to push oneself up and over the top of the bar and down again. So let's look historically. The pole vault record from about 1910 up through about 2000 is the last time I looked this data up. But you can see there was a considerable jump upward in the pole vaulting record, and then a gradual progression. So it was in this place here where technology made all the difference. And now technology is helping, but also things like strength training and nutrition and other increases in the ability of the athletes is helping. And then for women, notice, here's the thing, women weren't allowed to pole vault for a long time. When I grew up, women didn't pole vault. So the record here only goes back to 93, and I only got up through about 2009. So it has gone up, and it went up pretty dramatically here. But I think we can probably look at this and say, well, that's just because finally there were getting to be enough women doing it, because now they were allowed to it, that they got good at it, and it's been progressing ever since then. Okay, so that's an example of potential energy in the form of elastic potential energy. While we're not going to calculate anything with that, that is a useful thing to consider.